Thank you, Prasadanya. So we'll start right away the next session. Now, the next session is more on a discussion on the similar issues. And I'm sure that the people, the stalwarts which we have collected here will make this session equally interesting and equally informative. I'll request Dr. Prabhakar Shukla to briefly introduce the panel.
Yeah, thank you, sir. So today we have a very dynamic panel here with us, and all the panel members, they have a demonstrated history of research in the field of climate change. Introducing first Professor Amit Garg from Indian Institute of Management, that is IIM Ahmedabad. So his specialization is in energy, climate change, and sustainable development issues. Professor Garg was facilitated by the Prime Minister of India in 2007 for his outstanding contributions to the climate change research. He was also prominent member and contributed to the award of Nobel Peace Prize to IPCC in 2007. He received the Distinguished Young Professor Award for Excellence in Research in IIM Ahmedabad in 2010 and Outstanding Researcher Award at IIM Ahmedabad again in 2016. He has worked on a large number of research and consulting assignments for the reputed national and international organizations, which includes the co-chair of IPCC also. And next panelist here with us is Professor Krishna Achootarao, and who is the head of the Center of Atmospheric Sciences and Associate Faculty, School of Public Policy at Indian Institute, that is IIT Delhi. His area of interest includes climate risk assessment and detection and attribution of climate change. Professor Rao has contributed as a lead author in the 3rd, 5th, and 6th assessment report of IPCC. Also, he was contributing author to the IPCC's 4th assessment report. And he was invited by UNEP panel for Asian Brown Cloud project. And to his credit, he has a large number of scientific research papers, book reviews, technical reports. He is active member of various reputed scientific, national and international journals and societies. The next speaker with us, the panelist with us is Professor Sarath Kumar Jain. And Professor Jain has 38 years of experience at the National Institute of Hydrology. And after his superannuation from NIH in 2020 as a director, he is serving as a visiting faculty in Department of Civil Engineering at Indian Institute of Technology, Roorkee. He was Director General of National Water Development Agency for a brief period of 2017. His group has developed a software for hydrologic analysis and has set up an experimental basin in Lesser Himalayas. Dr. Jain is associated with various government ministries and departments like Ministry of Environment and Forest and Ministry of Earth Sciences, etc. Recently, he has appeared in the global list published by the Stanford University of top 200 scientists in his field of work. And the next panelist here with us is Professor Arpita Mondal from IIT Bombay. And she is serving at the Department of Civil Engineering and Interdisciplinary Program in Climate Change Studies at IIT Bombay. Her research focuses on hydroclimatic extremes, like how they can be characterized, what causes them, and how they are likely to evolve with climate change. She uses a combination of statistical understanding and computer simulations. Professor Mondal received Early Career Research Award from Engineering Research Board and Inspire Faculty Award, both funded by Department of Science and Technology, Government of India. She also received an Asian University Alliance Scholars Award. During her PhD at ISC Bangalore, Professor Mondal had received the Endeavour Research Fellowship from Government of Australia, Fulbright Nehru Scholarship, and also the travel grant for EGU. She scored first rank in the university at both UG and PG levels. So I thank you all for accepting our invitation. Now I request Professor Gosain sir to please focus on the research themes around which we will be spending our panel discussions.
Thank you. Thank you, Prabhakar. So as we have learned that through various presentations, that is a very, very complex issue which we are trying to dwell on. Now I have tried to put up some questions which we should do some introspection with, and this is a scientific gathering. We should try to spend the next 1 hour to really make use of the availability of our experts who are very knowledgeable and can help us in finding the right answers to these questions. The first question, which I feel is very pertinent, is that first question is, are we satisfied with the available science of climate change for India with respect to various aspects of climate models, the emissions, how we are getting the emissions, whether we have the full science available, and then finally the impacts and adaptation. So we'll take up one by one. The first question is that whatever we are using as scientists as projections, and many times you find that we start looking at the bias correction and all those related issues, which means that we are not able to predict our past historical observations which we have collected. That also gives us some uneasiness for the future when we apply the same model, which is not able to predict the present or the past, then how we are going to be certain about whatever we are doing for the future. And then the scenarios, the assumptions going into the scenarios. So that's the first question, I think, which I like my audience to really understand from the mouths of the experts, mainly to Professor Achootarao, that how do we satisfy the common people in getting this understanding properly? Professor Rao.
Thank you, Professor Gosain. Pleasure to be here, but let me dive into the questions you have posed. So some of the work that has gone on within the country and outside and has been assessed in the IPCC report is actually, to my mind, pointing at where we still have gaps in our understanding. So if you look at climate models or our understanding of what has changed in the past, is a question that I, working in the detection and attribution of climate change, feel that we haven't satisfactorily answered things. One example is that there is an understanding that we have the rainfall over India has probably been diminished by the anthropogenic aerosols that have played a part. I mean, these global aerosol levels have come down in the past few decades, but still over India, there is still a large aerosol burden. And I think we don't fully understand how much of what changes in precipitation we've observed over India are really due to anthropogenic aerosols, because it is not something that has been fully satisfactorily quantified. Because one of the additional issues that comes up locally, regionally within India, and this goes back to what our climate models have been asked to do, is these climate models have not taken into account the use of irrigation water, because irrigation, from some modeling experiments that we have done and various other groups have done, there is a strong indication that at least over India, because we are probably the biggest user of irrigation water globally, is that this has an effect on rainfall patterns. Now, these are modeling experiments for sure, but we don't have a concerted effort underway to fully understand this. And most models do perform badly over India, partly because of not having irrigation in them. So I think this is a lacuna that we should be cognizant of. We actually don't even know fully well how much irrigation water is added in India, not as a total, but the seasonality and the spatial extent of how much irrigation water is actually added for a modeler to take it up and use it. The different estimates that there are quite different. So I think with just understanding the past climate and being able to model the past climate, these are two major problems that I see: the aerosols and the irrigation water. These are regionally going to be extremely important for us to model, and we don't have a handle on that. I have other comments on emissions impacts, but I'll hold it.
Yeah, fine. I think that that means that what you're saying is that the science itself is quite fine, but what goes into the models in terms of the available data, that many times is the bottleneck, and we don't have the appropriate data going into the models to get proper results. Am I right?
That is one part of it, and also to then be able to say what did the aerosols do, what did the irrigation water do to our rainfall and temperature patterns. So that
process is also.
Yes.
Fine, thank you, Professor Rao. Now I'll go on to the Garg, just throw some light on the science of emissions in India and how we are really capturing the proper emissions. Are there still gaps while getting the handle on the emissions? How much emissions India is creating from different sources?
Professor Gosain, first of all, let me thank you. It's a very, very august gathering, I must say, and I'm not a climate scientist, I'm a water scientist. You gave me the privilege to come here and attend that itself. I'm very thankful to you. Thank you. So I think on mitigation or an emission science, there is still a lot of uncertainties, no? Like even in energy emission, where people say that it is quite known and certain, we have the sources, but there also, I think there are up to 10% uncertainties there in emission estimates. If you see emission estimates from some other sectors, agriculture, application of N2O, and that is fertilizer and emission of N2O, the uncertainty may be 50%. So these uncertainties, when you combine them together, I think there is a lot of things to be done. But I think uncertainty we can live with, because uncertainty is everywhere. And we have to decide under uncertainty. The policymakers have to decide with all the ranges we throw at them. I think what is very critical is many modelers on mitigation, impact, adaptation, globally, they're talking about global top-down impact integrated assessment models, IAMs, global. Now that I am not able to digest that, because at a global level, the amount of disaggregation possible is not so much. So I think what we must try as a country is try to create bottom-up integrated impact assessment model. Bottom-up means very finely gridded, maybe even 30 meter or district level models. I think district levels are good because it links directly with administrative units where policymakers can decide and take direct calls. So if we are able to say that these many districts are suffering already 1 degree centigrade temperature increase or precipitation 75% of districts, that catches their attention, and we then can integrate it with maybe adaptation actions, integration. Now states are creating their state action plan on climate change. With this type of I think activity, policy and action could be linked with science, which is greatly lacking in our country. I just recollect, maybe Professor Gosain, you will also recollect, Professor Mitra tried to create such a model about 20 years back. You were there, Professor Shukla, Professor Ravindranath.
Yeah.
Somehow we could not succeed, but now we have the science which has further gone by 2 decades. So I think we have the capability, and Professor Gosain, you have been creating and making your data openly available and accessible since many, many years. The time when India as a country should try to work and try to create, I think, a sense in the global things that India is not a information taker, or just you say something and we agree, but we should be able to create our own position. So I stop here and then maybe we'll come back later.
Yes, Professor Garg, I think you have brought in a very, very important aspect, which we'll be covering in the subsequent questions also, that when we'll talk of policy and what need to be done for with respect to the adaptation. I think I will revisit that, because this suggestion of yours that take the district, because many times when we talk of water, we always say that we should be talking of natural boundaries, but that is not where the action is. Action is at the district level, where the money flows, where the district magistrate is the one who's the person who's distributing that money and distributing the work and getting the things implemented. So we'll come back to that in a while. There's a very important thing which I think you have brought up. I'll now like to go to Professor Sharad Jain. He has immense experience in water. I'd like to know that as far as the impacts are concerned, when we talk of impacts, the impacts of climate change, with whatever data, whatever projections we have, how much satisfied you are with the science of that, whatever outcome we are having? Are we very much satisfied with that, or there are some missing links, there are some things which are still needed to be really tackled properly? So can you please throw some light on that aspect, which you have been very actively working also on?
Thank you, Professor Gosain. Again, it's a pleasure to attend this webinar, which is very informative, and the questions that you are posing are really something which force a person to think. So regarding this impact assessment models, I have some views. I think the way we are using these models for assessing the impacts is not adequate looking at the problems. And I will like to cover 2 aspects. One, of course, is data. This aspect, although it has come earlier, but I would again emphasize that we need better monitoring climate variables. We need better monitoring for soil related variables. And then we have very limited data in our country pertaining to withdrawals for various uses, including irrigation, industrial, etc. And if you don't have adequate data, then you are not able to calibrate your model properly. And so the outputs also will have a lot of uncertainty. In the water sector, the models that we are using so far, or till few years ago, emphasized only on hydrologic aspects. But now people have realized that in addition to hydrologic aspects, we need to build more closely other aspects, including environment, agriculture, forestry. And then somehow the social aspects need to be built into our models. A limitation of the existing models are that these are static models. So if you run the model for a time period of say 20 years or 25 years, typically the land use is assumed constant and withdrawals are also assumed constant. But we know very well that these variables are changing a lot with time. And so if we calibrate and validate our model with static inputs, then the results are going to be approximate. Another weakness which I feel is that many times these studies are done sitting in the office room, and people rarely go to the field and verify their output. While it is very necessary, because hydrology is a science which is practiced in the field. So before we set up the model, during validation, etc., it would be helpful to go into the field and ensure that the variabilities and the realities of the field are correctly built into the models, and the assumptions that we have made, these assumptions are realistic. We have not grossly oversimplified the representation. Then just now this question of natural versus administrative boundaries was also raised. In hydrology, we do follow natural boundaries, but as you rightly said, that for decision making, political or administrative boundaries become important. So there are attempts, and I think that is one thing which we need to focus, that finally the interpretation of the data should be in terms of say state boundary or district boundary, and the impacts also should be highlighted concerning these boundaries. So that is my brief response at the moment.
Thank you. Thank you, Professor Jain. Now I'll go over to Professor Arpita Mondal. Arpita, since you have, I think you are a younger person and you have much experience in terms of even handling the climate models, as well as you are belong to the water sector. So I'd like to pose the same question to you again, that how satisfied you are with whatever you are doing with respect to the uncertainty in both the things, and where the gaps are.
Thanks. First of all, thanks a lot, Professor Gosain and Professor Bhanya, for giving me an opportunity to be a part of this panel. And clearly, I have much to learn from all of you, more than what I can offer. In terms of modeling science, and I'll touch upon a little bit of climate modeling also, because of some experience of working with aerosol scientists and climate modelers, collaborating with them at IIT Bombay. So I think in terms of modeling science, when it comes to climate models, I think we have a lot to cover, because the models are not able to get the trend of the overall monsoon right. And also a lot of the rainfall is dumped over the ocean vis-a-vis the land. So there is spatial as well as temporal biases. In terms of aerosol emissions, extending what Professor Achootarao already mentioned, we do have the aerosol emissions in India are a little unique as compared to other world regions, because we have a lot of absorbing aerosols in the form of dust and organic carbon. And these absorbing aerosols have a totally different radiative and absorbing properties as compared to sulfate aerosols, which are more abundant in other world regions. So, but none of the Earth system models globally account directly for these absorbing aerosols. So these are some region-specific science that is still not being considered. When it comes to impacts, both for water resources and for agriculture, I think a lot more observational data needs to be collected and provided for addressing these science gaps, for addressing these uncertainties. And with the recent efforts of the water resources information systems of the CWC and NIH, a lot has improved on the water resources observational side, but I think agricultural yields is something where we do not have good quality and quantity of data. So our understanding of the processes leading on to these impacts can improve only if we have better observations when it comes to impacts. And also one small extension of this is when we calibrate models, as Professor Jain was also mentioning, we need a lot of dynamical data. Vegetation is something that we treat as constant, both in climate models as well as in hydrologic models. Reservoir operation is not considered. And our basins, none of the basins in India, I think, are truly what are called natural or virgin basins. So a lot of human interventions are there, and we do not have good quality of data on those, which can be an input to the model. But we also need to take into account this fact that the parameters of the models that we calibrate, we are essentially assuming them to be constant for the future scenarios. And this is the problem of stationarity, be it the biases or be it the whole calibration process is assumed to be stationary. So, and that, I mean, of course, there have been a lot of debate in the hydrologic literature as to whether stationarity is dead or alive or immortal or undead. So we have lots of views on that. But I think there's a fair bit of consensus on the fact that we cannot, under changing situations, changing circumstances, we cannot assume these parameters to be constant over time. So that is also one aspect where the science needs to improve a lot.
Thank you. Let's move on to the next question, which I had put this question later, but I think this is the right time to put this question. That have we sufficiently understood the interaction between sectors and systems to plan good adaptation for water sectors? And there are externalities of whatever you do. There are many systems, many sectors which interact with each other, and we have listened to the previous presentations, and it has come out very clearly, and all of us understand that. Now, under that, don't we feel that the science, what we are using, is not feeding into the policy-making process? Is a separate issue that policymakers never ask us, even as such. They make the policies without even getting the science into it. But even if they want to do that, do we have a good science available which can feed very effectively into the policymaking? That's the question. So I'll first of all, I'll go to Professor Rao again, that from the system you deal with, you are not dealing with the system, you are dealing with the atmospheric systems. How much is the lack of knowledge there, and how much is the lack of understanding, which still is not going into the modeling effort properly, and there are gaps? Then we'll come to the other terrestrial systems.
Right. So not to flog a dead horse, but I go back to the example of irrigation, right? For example, it's water is just so intricately linked with agriculture and agricultural practices and management that these two cannot be separated out in terms of how the atmosphere looks at it, because the atmosphere looks at what the soil moisture is, and if we don't have any handle on what water is being added, then clearly we haven't fully understood the interactions that go on, because this is not a purely physical system. The moment you start bringing in a human induced addition of water into the mix, the intervention of a human action that is going to certainly affect our atmosphere in some ways. So I think just with that one example, there's of course many more examples of where these systems can't really be separated out. These are artificial boundaries that we have because of how our disciplines have grown. But I think I would say that it's time to sort of have some integrated approach to this. If there is a way to build a systems approach, it may or may not be like these what we have now as standalone models that are doing various parts of it. But is there a way we can integrate these, think integrally what happens to water, what happens to the atmosphere, what happens to agriculture, So unless we have the ability to come together and model or understand them as a whole, we will always have this issue of which came first. Did the water from the irrigation affect atmosphere, and did that affect rainfall, and did that affect hydrology? Did that affect irrigation, etc.? So it could be a circular argument. So I think we need to do.
Yeah, I fully agree with you, but we also miss that part, that when we want to look at the impacts, we are in a position to really represent the irrigation properly. But if you are given as a follow-up question, if you are given the choice that, okay, you will get whatever you want, what kind of data on irrigation you feel that is necessary to be collected at the country level, which can go into the models and it can improve the models? At what resolution? At what temporal interval? Can you throw some light on that? When you have been given a wish list that will provide you whatever you want.
Okay, if I had all freedom to have anything I wished, then I think having the amount, timing of water added through irrigation at, let's say, at an acre level, a single acre, or even slightly bigger than that, let's go to a kilometer scale. I think that should be sufficient. I mean, whether we can do this with remote sensing is a question. I know that Vimal Mishra looks into things like that, looks at evapotranspiration and other things. Perhaps there is some day soon that we can actually remotely sense this. But I think if there's a way to get this data somehow at a fine enough scale, there could be a lot of interesting science done to understand it.
Thank you. Now I'll go over to Professor Amit Garg. I know he has been dealing with the nexus between energy, water, and agriculture. Yeah, we have worked together also on some of the projects. So will you throw some light on the comments of these interactions and how they can be captured and where we stand as far as the country is concerned at this time?
Professor Gosain, I'll just put 2 or 3 points. First is the total water consumed in India, about 1200 billion cubic meter per year. Out of that, 75% goes to agriculture. So we want to understand the whole integrated approach. We first have to see how we can reduce this integration, this water consumption with an increase in crop yield. That is first important thing. We cannot say that we don't give water, we don't. So that is number one thing. So for this, maybe at district level, we have to suggest the crop baskets. We have to suggest technologies there, because if we have to grow, let us say, rice or even sugar cane in Gujarat, this is criminal, I would say. And with the canal irrigation coming here, it is happening. That is not good, no. So that is first thing to be required. Then we have to see what technological changes are required. For example, in power generation, why should we have a water cooled once through cooling of power plant? Why can't we have a cyclic cooling, or why can't we have air cooling? So that is a specific technology level. Similarly, in residential sector, in commercial sector, and I would say that we need not hit the last decimal place in these things. No? Even 25-30% accuracy is good enough. Because then if you are doing this across sectors, we get a sense at very micro level, very operational policy level, where it is possible. So very short answer is yes, we have not sufficiently understood. We have not. And we need to have some bottom-up assessment done for this. I come back to my last point, and we need to integrate across sectors, across, let us say, time frames also. Thank you.
Thank you. Yes, Professor Jain. Now, when we talk of integration in water sector, what we are missing and why we are missing that. Let me also add, if you talk in the water sources ministry, we always been claiming that we are doing the IWRM, Integrated Water Resources Management. Are we doing that seriously? If we are not doing, what we are missing? Yes, please.
So you are right. I don't think we are doing IWRM. And coming to question, I think before we can answer this question, we need to first carefully know what is the present state of the system. For example, how much water is there and how much water is being withdrawn or being used. Like Professor Garg just gave one estimate of current water consumption, and there are many other such numbers, and there's a quite big difference among these numbers. So I think before answering this question, we need to carefully understand what is the current status of the system, how much water we have, how much we are using, where we are using, and for what purpose we are using. Coming to IWRM, I think in the garb of IWRM, we are just managing water. We are not managing associated resources. So in my opinion, if we really want to do IWRM, we should have models or management for water, environment, agriculture, forest, and energy. At least these domains should be covered together. There are many more other domains. And regarding science, we should use the knowledge of meteorology, soil science, geology, hydrology, agronomy, and sociology. So many science disciplines and so many water use disciplines should be coordinated before we can really say that we are practicing IWRM. Then for practicing IWRM, it is also again necessary to work with the society. You know, we need to work with the farmers. What drives them? What is their behavior? And if we want to change their behavior, what are their concerns? See, if we say, ask a farmer to change the cropping pattern because enough water is not there, he may not believe us. Because if he loses one crop season, then his debt will be mounted and he may require 3-4 good years to overcome that debt. So to introduce and practice these changes, it will be necessary to understand what are their concerns, and then only we can think of changing behavior and changing cropping pattern. So I think all these different sectors need to be studied in an integrated manner by a multidisciplinary team, not only Water Resources Ministry, but it should be an interministerial effort so that we have realistic solution.
Thank you. Thank you, Professor Jain. Yes, Arpita, you want to add in the IWRM strategy, what we should be having for having a better water management?
Yeah, I think much of it is already covered by the three speakers before me. I think the one sector which I would like to mention in addition to all the sectors which Professor Jain mentioned is the infrastructure and particularly transportation and structural engineering sectors, because I think even within civil engineering, the structural group doesn't speak to the water resources people, and the water resources people does not speak to the transportation, and vice versa. But we do see that, these are times where multiple hazards are occurring together, and a single silo approach is not going to work. So for example, at IIT Bombay, we recently showed that, climate change can make bridges more vulnerable to earthquake related damages. So, how earthquake leads to scour, flooding, and how that is going to be exacerbated by climate change. So I think as all the three professors, all the three scientists have mentioned before me, a lot needs to be communicated between these sectors. Yes.
Thank you, Arpita. We'll move to the next question, which is equally important. What are the research gap? What are the gaps between research, policy, and governance for adaptation with special reference to water? Because we're not yet talked of what adaptation options are available and how to arrive at those options in the context of India. That is a key question. And then it is also associated with the policy issues, the governance issues. So we'll try to maybe throw some light simultaneously. But let's first look at what kind of adaptation options are relevant, and they can be called good adaptation options. How to go about it? Because not only in India, globally, there's a lot of trust given to this aspect of adaptation. That is my question. I'll first start with Arpita, because she shouldn't be getting the last chance every time. So Arpita, if you are given the task of coming out with the good adaptation options for water sector, what do you have to say? How you go about?
Yeah. Thanks for letting me speak first, though I honestly feel that I think Professor Jain is the most suited to answer this.
We'll come to him also.
Yes.
Don't worry.
Yes. I think a rather simplistic approach to a solution would be, how they say, for food, you rely back to what is traditional and what is good for the local economy and also for the global ecology. Similarly, when it comes to water, I think we should stick to more traditional ways of managing the water systems, which were proven to historically sustain themselves over a long time. For example, in South India, we had the tank system and so on. So that's just one example. I think it's now time for us to reflect back and see what is so unique about the region I'm interested in and what has historically sustained in that particular region. And we should strive towards building technologies which can bring that sustainability back. So which I think a lot of the science and research that we are doing is kind of emulating other regions. So for example, somebody is running a GCM and then followed by a hydrological model, sometimes even linked with hydrodynamic models for flooding, inundation depths estimates and so on. But do we really need to do it for my region, for my local water resources management? I think we need to really bring out the uniqueness of our region, our systems, and focus on the challenges with respect to those. Approach should be local and specific is what I feel.
Okay, thank you. Over to Sharad now.
Yeah, thank you. So I think Arpita has set up very good foundation. Let me try to build on those foundations. I think Professor Gosain, for good adaptation, we first need to understand why are we needing adaptation. And I think few critical things that climate change will impose on us is that the mean and variability of the variables will increase, and they will continue to increase with time. So I think the challenge is to better manage the variabilities, and for that two options are available in water sector: hardware and software. So I think flow variability can be best managed by appropriate infrastructure, including reservoirs. And then we also need to take up groundwater management more comprehensively, because groundwater is providing us a cushion to manage droughts. In addition, of course, the management part is something we have not paid adequate attention, including reservoir operation and things like that that were mentioned. In my view, we also need to have a relook at floods. So floods should not be just seen as a menace. This should also be seen as an opportunity where water is available. So flood management should be to conserve the water as well as reduce the damage. I also agree with Arpita when she says that implementation of adaptation should be at regional level, because we have region-specific problems, region-specific climate, and region-specific behavior of our society. So that should be factored in while developing adaptation plan. For example, an adaptation plan which may work for Northeast may not work in Rajasthan because the climate is different and the people respond to extreme events in much different way. But at the same time, the option of long distance water transfer would also be helpful because we have widely varying water availability across the country. So we need to, really transfer water from the surplus zones to the deficit zones so that this variability is also managed, both spatial as well as temporal. I think these are some of my thoughts on managing adaptation.
Thank you, Professor Jain. Professor Garg, you have been dealing with a lot of policy issues. So I think I'd like to put some light on what we are missing in terms of the policy for the adaptation.
Professor Gosain, since you invited me some time back, I've been looking at various policies. I could find out 36 central policies on water. And I could look at 7 states, I could find 27 policies on water, state level. And these policies are not very small policies. These are policies that include creation of data, creation of integrated multi-sectoral approach. Let us say for Kerala, there are common command area development water management program of Government of India. Then of course, there is a hydrometeorological data dissemination policy. So there are policies and huge amount of money has flown through that. And some projects have been closed, satisfactorily closed. No? So, and we are still talking that they are not there. So I think we need to create a database for all the policies state level. There is no point in just charging the states or central government or policymakers that you're not listening to us. They are already creating policies. They are maybe listening to somebody else who is a, let us say, sufferer or user or stakeholder. So we have to integrate with them. That is my first point in this. Second point is what I find missing in all these policies is targets. Targets are not indicated for any policy. So there, I think we scientists can indicate and suggest targets for every policy that this, if you want to have a maybe river basin management system, these are the 5 targets you should have for this zone. Basin level, sub-basin level, whatever. And the next level, what I saw missing is no mention of indicators, Professor Gosain, that if you want to have these targets, what should be the indicators to follow? This could be like for power sector, the Government of India has given 2.5 liter water consumption for creation of 1 kilowatt hour of power by coal plants. So this target has been given, you cannot breach it. So what is the implication of this target for various levels? So I think that type of indicators are very, very grossly missing. We need to do that. And we need to, I think, engage at very grassroots level, let us say at state level first and look at district level, because I know we have been creating inventories for gridded inventory, but then we discussed, for Shukla and we decided to create it for district level. Then policymakers can directly pick it up and take their attention. If we say these out of these 720 districts of India, these 180 districts are having severe water shortages. Everybody may know it who is living there, but when we highlight these things, it grabs attention. So, and then we can say that there are 20 policies already, but still for last so many years, this has been the trend. I think that is important. We should work with policymakers, not dictate from a very sitting maybe ivory towers that we are big modelers. I'm sorry. I also take pride that I'm a big energy modeler and working on water, but that is infructuous. That doesn't matter at all until unless our research does not help the people on ground. Our research does not help policymakers to make the right policy. Our research does not help policymakers to create the right targets and indicators for the policies they have. I think we need to think on. That is my idea and suggestion.
Thank you, Professor. Thank you, Professor Garg. I'll like to share with all the panelists as well as the audience. This is a very important thing which I think was done around a couple of years ago. There was a delegation put up by GIZ. We had gone to 4 different states to think in terms of and taking the states into consideration that how the integrated water resources management should be implemented. And I'll just reveal that what we had come out with as the recommendations. First thing we said was that each river basin in the country should be analyzed separately because the conditions in each river basins are different. So we should find out at the basin level, what is the status? Are we having the deficit in the water availability versus water supply, water availability versus demand? And that is actually reflected in the fact that almost every river basin in the country, the groundwater table is going down. That means we are extracting the groundwater table to take care of this deficit which is there. So every year you will have the falling of the groundwater. And having done that, you should then go to the level which is where the action is. Having understood that what is in different parts of the basin, you can look at the sub-basins and then have an interaction between the basins and the districts, or the sub-basins and the districts. What is the status of the sub-basin at the district level? And then make the plans for the district level water audit. The water audit should be done at the district level, at how much water they have and how much is their demand, so that you can start thinking in terms of how to really reduce your demand if the demand is too much. As you said that 85, you said 75%, but it's 85% agriculture usage of water. So if that 85% is the agriculture use, then you can go to the modeling exercises and find out how much is the legitimate use for the agriculture. If you really need to change the irrigation methods, which is the main reason for the low efficiency of water use, then what kind of investment is required to really change the irrigation methods? And then you can look at how much is the amount of water which will become available because of the enhancement of the irrigation efficiency. Now, once you have this available water, you should see that how much of that can go into satisfying the deficit. How much of that you still have the surplus? In some cases, it might become some surplus. The way it should be allocated. Similarly, the same thing has to be done to the water which is being used for the domestic purpose, the urban areas. How much water you can get from the reuse of the STPs, the sewage treatment plants. Now that water can be recirculated. So how much is the reduction in the water demand for the areas which are urban areas? These exercises are to be done to really look at the district level. And then we said that for the district, how many programs are already there being implemented in the district? And that is only the knowledge which is the district magistrate has. He should converge these programs at that level and see that which are the overlaps. If there are overlaps, that should be reduced, and you will find that you have surplus money for basically because the same money is being used for doing this similar things at the district level, at the local level. And this is the only way you can go over a longer period with the objective that you have to take care of the deficit. You have to bring back, and when you are doing the river basin management plans, you should also find out under the natural conditions, where the groundwater tables were. So that should be your target, to rejuvenate the groundwater to those levels. At least you can approach to those levels, not maybe attain those levels so that all the environmental functions can start functioning. So I think these are, so the time is short, but I think these are the things which are required to be done. And second, we shouldn't be using these adaptation options are not for the climate change. These are for the present variabilities. We should think of climate change only when we have taken care of the present variability of our systems. Can we address the present variability? If we can address the present variability, then we are much better to address the future variability. So I think our target first should be, maybe then the money is coming in the name of the climate change, but our target should be first to really rejuvenate our systems, to bring them back to their environmental and hydrological health. That is what is required. If we can do that, we can achieve many more things. And I think we are really short of time. I'll stop here.
Sorry to interrupt you, Professor Jain. The question is, are there particular basins or sub-basins where the future research should focus on and why?
Okay.
Okay, yeah, thank you. Thanks for clarifying. So I think in my opinion, the basin where water stress is highest, those should be the basin that we should take up for study first. And I think just now we were discussing very important thing. When I entered the profession about 40 years ago, there were talks that, water is best managed in the context of river basins, and we should have river basin authorities. But even after 40 years, we don't have river basin authorities in a meaningful way. Now, whether this is a policy gap or this is a governance issue, that I leave as it is. So coming back to the question, I think the basins where we have maximum water stress, those should be the basin where we should take up research. And we should try to understand again in those basins, what is the total availability of water, what are the present uses of water. Then another thing which we have not touched here is water quality. In many of our basins, the quality of water is extremely poor, and poor quality water is highly detrimental. So we need to understand how to manage both quality and quantity together in a manner so that we have sustainable development. I think that is my...
I'll add on to what response has been given by Professor Jain. I think another way which also was mentioned by Professor Ravindranath, that one way of doing it is to look at the vulnerability assessment, where you are looking at the vulnerabilities not only with respect to the biophysical parameters, you can also add the environmental parameters, you can add the socioeconomic parameters, and we have done a lot of work in that direction. We have done the vulnerability at the district level, even at the sub-district level. And if you can write a mail to us, we will send you some more literature on that how the vulnerability has to be done, where many other parameters are also to be considered, so that when you are investing money for the upliftment of the society as well as the taking care of the environmental conditions, then all aspects are required to be understood first, and you can then look at what is the level of vulnerability and select those areas where the vulnerabilities are high. So that is the right way of approaching that problem. So I think we are done with the session, and basically, I would like to thank all the panelists for a very wonderful discussion. And before we close, I'll request Dinesh to really put up a vote of thanks. Dinesh, over to you.
Yeah, thank you, sir. For a young research scholar like me, it is really good to see all the eminent peoples together and having a conversation about this important issue, climate change, which has a national, regional, and global importance. Well, the event like this cannot happen overnight. It requires detailed planning and execution. So we have been fortunate enough to be backed by a team of very motivated and dedicated colleagues of Newcastle University and IIT Delhi team who know their job and are more result oriented. I, Dinesh Kumar, on behalf of Team IIT Delhi and the entire Water Security Hub, extend a very hearty vote of thanks to all present here. First of all, I wish on behalf of India Water Security and Sustainable Development Hub to thank the UCRI Global Challenge Research Fund for supporting the project, which has enabled us to organize such events. I wish to recognize the efforts of the management and the operation team, Water Security and Sustainable Development Hub, Newcastle University. I also thank the unconditional support given by the Indian Institute of Technology, Delhi, FITT, and School of Planning and Architecture, New Delhi. I thank the eminent speakers and panelists for accepting our invitation and taking their precious time to be part of this webinar. I greatly acknowledge and appreciate them for providing us with the valuable insights and different perspective about the climate change and its impact on us, and highlighting the importance of adaptation for sustainable development of our society as well as for our country. The presentation and panel discussions were really insightful. I'm sure that all the participants are in a position to enhance their understanding of this very important topic, which touches everybody. Also, I thank all the attendees for taking your precious time to join us and actively participating in this event and posing a very good questions. At last, I thank everyone involved in organizing this webinar, directly or indirectly, for making this a successful event. Thank you all.